introduce yourself and your role, your name, and something that's a fun fact that's not on your LinkedIn profile. So we get to know you.
Okay. I'm Jeff. I work at LinkedIn. I work primarily on text classification and some other general machine learning problems.
Sorry,
could you speak a little louder, please? I'm sorry. I am Jeff. I work at LinkedIn. I work primarily on text classification and general machine learning problems. I work on several products. Probably the main one that you would most be familiar with as an end user are the smart replies in Messenger, which is based on a multinomial classification of potential replies, and then we suggest the top 3 or so. One thing, before LinkedIn, I worked at Facebook for 4 years, and before that, I did my PhD at the University of Illinois under Dan Roth. So one thing that isn't on my LinkedIn profile, which is fun, I spent half of Saturday rebuilding a Windows encrypted file system key so I could get access to my own files based on my backups. That damn Microsoft. I don't know who would work for them.
Hi, I'm Vita Markman. I also work at LinkedIn, software engineer. Currently, I'm working on the international engineering team, appropriately. Essentially, our mission is to make LinkedIn delightful and appealing to members in international regions, as well as in new markets inside of the United States who, for one reason or another, are not heavy users of LinkedIn. My background is in NLP and computational linguistics. I kind of went from the more research-oriented work into more engineering work. Right now, primarily my work involves improving and working on job search ranking models for new markets, which is segments in the United States who don't use LinkedIn much, and we want to improve that. The one thing on my profile that the one thing that I do for fun that's not on my profile is I dance Argentine tango. That is my other huge hobby.
I'm Anna Simoins. I work for Intel. I also have an NLP and computational linguistics background. I did work in a number of products. Like before Intel, I worked at eBay and I was in machine translation there. And at Intel, I worked primarily with conversational agents, and then I transitioned into strategy. Today I'm at the AI products group, doing strategy for deep learning acceleration. And a fun thing about me that is not on my LinkedIn profile is I used to sing in a band. And the reason it's not on my profile is because it wasn't a very good band.
I'm David Freeman. I work at Facebook as a research scientist engineer. I work on it's called site integrity, but basically we're responsible for stopping all bad behavior on Facebook, including spam and bot activity. Before that, I worked at LinkedIn, which is how I know many of these people, doing similar things. And I do not have a machine learning or computational or linguistics background. I actually have a math PhD and did cryptography for a very long time. And something not on my profile that might be relevant here is I can count to 10, even 8 languages.
Hello everybody, my name is Yewser. I'm a staff software engineer at LinkedIn. I'm working for like a post developers trying to make more connections and invite more people to join LinkedIn. So the product our team do is, I think you probably know, it's called People You May Know. So we are doing this like people recommendations to our users to hopefully advance their career to connect people that will help them.
Excuse me, can you be louder? Cannot hear.
Should I repeat what I said? Okay. So very hard about this, and I think. Okay. Got it?
Yes.
Okay, so I said I tried very hard to think what is fun thing that is not on LinkedIn profile. Maybe not fun. I was the only girl in my undergraduate department. So like for the major, for the class like that is specific to all major, I usually need to be there. Otherwise, it's very obvious if I skip the class. Yeah. That's it.
Thank you. So as you can see, I've constructed the panel to have three components of machine learning. So we have the engineering representatives, we have big data mining, applied machine learning, ML, and then on the math side, the predictive analytics and to build the relevancy algorithm, and then on the applied linguistics with NLP and taxonomy and so on, classifications. So, as I mentioned earlier tonight, the big challenges for international is, of course, the lack of volumes of data. And at LinkedIn, when I worked at LinkedIn, we had the tendency that we saw was, of course, international users are late in the game. They're late adopters and maybe lower engagers. And so their profile completion was ranked higher than core English market new users. We didn't have, of course, labeled standardized data sets of company names, school names. So if somebody signs up in China, they went to school X, have experience in certain companies, they're not standard, those company names and all those other assets like titles. So we didn't have a standardized data sets of those multilingual assets. And so we couldn't really build, we didn't have that inventory to build, to index them and map them to IDs. And then, of course, the connectivity circles of international users is low because there are less people that in those countries that have onboarded on LinkedIn. And so my question to you is, now that a lot of the models are now, part of the solution for resolving for international is, of course, applying language agnostic machine learning models, deep learning, is a good example of that, or creating translation or other language specific systems. So, what is your experience, with language? Give me an example of a language agnostic treatment, and also what are the cases where language specific lacking creates a lot of problems. And I'll just give an example. When I worked at SaberMonkey, we used a lot of language agnostic signals. So things like number of questions users deployed in their surveys, or attribution channel in their entry point, right? In order to inform us as a behaviorism signal on the recommendation system, or to inform us on the personalized experience. So I'll start with you, Linji. For Q&K, knowing that with all the problems that we had in Q&K, what are the solutions that you're developing?
Yeah. So as mentioned, because in the international users, they don't usually have standardized data, and let's say for P1K, we are usually dealing with two problems. One is the liquidity. We need to generate enough recommendations, which we call liquidity, and most likely in US, for example, we are working on trying to improve the quality of those recommendations. But for the international market, especially for new users, the liquidity is number one concern. So how we do this? In general, we use when people register, if they do not have a standardized profile or something, so we just use people search with their local language of their member profile using their school or company, and then we do the search, so then at least we can generate some candidate for them so they can start connecting. And if like the other thing is because our recommendation mostly we're using the connection graph. Like after you connect to someone, then you can like walk like outside. But if you do not, if you are the isolated node, then it's hard to walk on your connection graph. So we really like use this kind of people search using their company or school information to get them started, and then they like we will have more like better quality recommendation in the future. That's we do. And the other thing is like for people who does not have enough connections, usually we use like your friend's friend, which is second degree connection. But for people who does not have enough connection, we go beyond second degree of the connection graph. Yeah, and also for some company, because their culture is different, we also do some country-specific model. Like we learn different like machine learning models for specific country because of the like the I would say like the data and the data pattern from different countries is different. So we use country specifics to help them more provide the recommendation they think they are more relevant to them, but not like global.
Yeah. Anyone who was jumping doesn't have to be by order. But I know we have that you. Oh, go ahead.
Okay, so well, the question is how do we do that sort of language agnostic?
So language agnostic, and then where does the
it
lack
break
of
down?
language specifics create problems?
Yes, so I work on fighting spam and abuse, which appears in all languages, and some more than others. And it's especially difficult because it's an adversarial game. So if you have somebody posting spam in whatever language, and you use specific language features, or give like a word blacklist, adversaries will quickly change their messages and get it out there even and get around your systems. So we found the greatest success is actually not using much language features at all, and really look at behavioral features, because the goal of spammers is to get the message to a broad audience, and there's only a limited number of ways to act to do that. So that's generally been the philosophy at Facebook and LinkedIn. This can break down, as you said, in certain markets, what's normal behavior is different than in other markets. People might just friend a lot of random strangers in certain countries. And we don't necessarily train country-specific models, but we have based on the country, sort of what the baseline should be to sort of correct for those cases.
I can actually speak. We had one product, a conversational agent that was a fitness coach, and it was originally built in English and with very intricate dialogue systems, right? So you could ask things in English to things like an opera, which is to say Marcus and Giselle was going down the road. She said something. He understands that the she is actually the girl, and it was the girl specifically that was mentioned in the sentence before. Obviously, very, very language detailed and very language dependent. And then we had the task of scaling that product out for Europe, like 7 or 8 languages at once. And one of the things that we did was basically abstract out of the discourse model, right? It's like understanding the discourse loops and the tasks that were done in the product, abstracting out of there, and then only translating or building out the language-specific layer for the questions themselves, but really abstracting the rest of the product. But I was going to actually point out that the problem you said, in terms of having lists or missing data for parts of language, is not necessarily a problem that is not English, right? And when I worked at eBay, one of the hard requirements we had is that we were translating, and we were not supposed to translate brand names, and there's not a list of brands right? And brands can be, every single word is almost a brand. So that was a very complicated problem, and we had to tackle it from very different parts. We used context rules, we used sum lists, we used all sorts of context-sensitive stuff to try to tackle that.
Thank you. So I'm going to give an example of where we use language agnostic models and also an example where it can present a problem. So for example, in LinkedIn is obviously a site available in multiple languages, over 20 languages at least, and members have profiles in different languages. So there's profiles in German and French and Russian, etc. Now, the search functionality, we can't imagine that we would index for every and have like multiple indices for each language. That's not scalable. So we use some rules to tokenize the data, essentially index the text for, let's say, member profiles so that people can be found on LinkedIn. Now, it turns out that suppose if you're searching for in another language, a language like German, it actually may be relevant to other languages like maybe Russian, that there is a gender information in a member's title. So suppose in English you see it with cases like actor and actress, but in German it may be with almost every profession. You would have like engineer and engineeress. There's like Entwickler and Entwickler, and it's two different words. And members who are female, they would write themselves in the female form, and that's completely standard. And our competitor in Germany, Zing, a different company, had received some negative publicity that they were unable to find when search term engineer is entered. They wouldn't be finding women because it's not in the index somehow, or the query doesn't match what's in the index. It's a different word. So we made sure that we don't have that problem. And I actually worked on that part, and essentially this is where the limitation of how we did our index initially was seen, and then we wanted to make sure that you can't just index in English. You never thought of this, and so it's not a problem, but in other languages you have to make sure that even if you index only one term, that at the query time there is some other functionality that allows to match for whatever the form that's in the index. So it's, if you say actress, you should find actor and actress in the same way you would find only one of these words. So that's an example where you really need to be aware that other languages have different grammars, and people use those grammars because it's their language, and they don't want to use only English-centric way, which is write themselves in the masculine form. Some do, but others don't, and they of course we need to be an equitable platform. So I'm happy to say that we are.
Speaking of language agnostic products, if you look at feed ranking on social media sites, feed ranking is actually, you might expect it to require knowledge of language or knowledge of the content. It doesn't really. You have very powerful social signals, and a post gets clicked 20 times out of the last 30 people who saw it, probably a pretty good post. You don't need to know what the post actually says. Maybe you want to know the user's propensity to click, maybe you want to know the user's connection with the user who made the post. These are very important. When you actually comes time to try and understand what the post means, it's actually hard to make an impact, because the vast majority of impressions for a highly trafficked newsfeed are going to be posts that actually see a lot of activity. So you already know a lot about them when the average user comes and sees them. So this is the case where you might think the language is important, but the benefit is not marginal, but harder to realize. Then in terms of developing other models where language is more important, let's say that we want to have a text classification model that predicts smart replies, for example. I'll just use that as my writing go-to product. One approach would be to try and find some external resource like cross-language embeddings, and now I can start to try and transfer my examples over to this embedding space. I have text, now I take all the words, I embed them using my English embeddings, and then I have some average embedding which should work just as well for Germany, assuming that my cross-lingual embeddings are good. And then I can make the same sort of inference, and then I have some labels, some potential replies that I suggest to you, and I have annotators translate those. Another approach you could use is use weak supervision, where you go and mine conversations from people, or you go and mine tweets. I mean, there tends to always be some source of text that you can leverage, even if you don't have the budget to pay annotators to label it manually. But yeah, it's never been too much of a problem in my experience. The key is, do you want to make the investment in terms of engineering resources, annotation resources, requisite to capture, increasingly small segments of the market after you go past English, and that's where the interesting business trade-off comes.
With Fuko also to proliferate to enhance engagement, right? Non-English engagement is lower. So when we launched that LinkedIn in 2014 in China, of course there were, it's a very low adoption market at the beginning, low market penetration. And so we actually used machine translation to create, first of all, creating the capability for users to actually have multiple multilingual profiles, and it would be like mirror sitting on a different repository that would replicate profiles in different languages. And so we would, even today, right, if someone today in China searches Kobe O'Brien in Chinese characters, they would actually land on the machine translated Kobe O'Brien Chinese profile page, right, and which would be the relevant experience for them, and that would bring on better engagement and reduce drop-off rate, from search, bounce rate. I'm curious about different cultural aspects. So there's language aspects, and then there's also kind of geo-culture, because even for a product like LinkedIn, which is supposed to be sort of, generic, it's for professionals all over the world, right? Expected behavior is similar. But even there, so if in the US, the assets of, recommending for PYMK, recommending people you may know, that recommendation system is heavily based on colleagues, for example, because that's trivial, it's pretty relevant. However, in Japan, colleagues is not a good signal because the perception is that if I am on LinkedIn, I don't want to necessarily connect with my colleagues because that's a perception of I'm looking for a different job. So pushing that in the recommendation system is not the best signal. In China, actually, seniority level within the domain and geolocation are the highest signals, right? So geolocation as a data set and seniority data set would be highest signals. So I'm wondering, and then also, in Germany, because of Zing, it's high competition, so LinkedIn is actually pushing instead of PYMK, GYMK, right? Guests you may know, because there are not enough connectivity circles, right, for cold starts, for onboarding. So I'm curious, what have you, experienced in your different domains in terms of cultural, and even if it's language agnostic, but differences in cultural behaviorism, expected behavior.
In the context of messaging, one thing that I think is very interesting, not just in messaging, but in use of the LinkedIn product as a whole, is that people in certain countries, for example, India, tend to be more formal in their speech. So they might start a message by saying "dear sir," where someone in the U.S. might just say "hey buddy." Probably not in the same context. I'm exaggerating a bit, but it is more formal. This can be a problem if you're trying to train a model from blobs of text from one culture and then making predictions for another culture. If you were generating text, for example, you might generate some missive like "Dear Sir, congratulations on the new job" for an American user, which would probably not be appropriate. So it does have to be taken into account. You have to watch for it. But overall, it at least for us, hasn't been too big of an issue.
Yeah, this is just to echo what you had already said, that in some countries, sort of your loyalty to your company is very important, so you do not want to be perceived as necessarily constantly looking for a new job. There also may be, so in the US, we're kind of very big in our skills, so LinkedIn skills is a big product, right? And so LinkedIn skills is like a feature, right? And we want to get endorsed, and we're kind of here's my skills, but in other kind of cultures, maybe a little bit kind of considered as boastful. So there's other aspects we're trying to focus on for other markets, perhaps different topics of interest for feed, different ways to engage members, not necessarily make LinkedIn more of the job app. A lot of US members think of LinkedIn as like where you go get a job, connect with other people, but kind of for job reasons. It doesn't have to be that way. It could be professional engagement. So to pivot the focus on new markets, like certain countries where it's not exactly cool to be showing off as you are looking for a new job, is to look at other areas of focus.
I think one aspect that comes to mind in that was very close to the project, that fitness coach that I talked about, right, when we developed it and we all of a sudden had to translate it into different languages, was that to complete the experience, it's a fitness coach, it's an authority, you're running, you're talking to it, it's giving you feedback and giving you suggestions, you can make questions. It turns out that a coach in Germany talks very differently to a person than a coach in Italy in terms of politeness, in terms of even tone of voice and the frequency that you will actually. So there are certain levels to adapt the experience to another culture goes way beyond just translating the string. Right? You really have to understand the culture and the expectations for the speakers of that language.
So I guess as I discussed, it's different countries, people engage in different behavior, and sort of different baselines for what might be considered standard or not. At Facebook, we kind of have a sort of a baseline set of policies. If you kind of let different standards proliferate, it becomes very hard to enforce and can seem arbitrary, sort of what's allowed where. So we try to maintain sort of a consistent line across various cultures in terms of what's allowed inside or not. What is different, and then we use this as strong signals, is different propensity of people in different countries to cross that line. How many people have gotten offers from any Nigerian prince, for example? So we can use these kind of signals and bake them into models to try to protect users in that country and around the world.
Like the example now, again, it's like we do observe in this when we are trying to grow the international company. I just want to add two things. One is like, LinkedIn, when LinkedIn started, like ask members to register, LinkedIn asked members to use, most of them use the email to do the registration, right? But later then we found, okay, there's a lot of countries, they are world without emails. So like China and some of like South American countries, like a lot of people, they do not have an email address. So but they have phones. So then we extend a product called Business Relevance, which is like, so you can register with your phones and you can import your like phone contacts to invite them to like register. And I think we got a very big success on that like product. The other thing I want to talk about is also like related to the digits. For example, in like India, a lot of people they use mobile to access LinkedIn. And then like when we added more features, we added more content on LinkedIn app, there's a size limit. And then after a certain time, they stop enjoying the new features because of size. And maybe they are not used the best like smartphones, which have limited memories, right? So like for them, in order to like release our latest feature, we have to really build concentrated on the important features and then really reduce the size. So like that's some problem like you never know until until you really go to the country and you realize, oh, that this is a big problem. They will not receive new features if you keep just increasing the features without like reducing this.
For mobile first countries.
Yeah.
So the next question is on doomsday, right? It's more on how recommendations on designing safeguards. Elon Musk has a OpenAI lab, and one of their, they built a Python-based library based on autonomous, basically kind of the next gen of machine learning that autodidact, right? Autonomous applied learning. And then one of the mechanisms, so it's so smart, it's called deep learning. It's so smart that actually in one of their experiments, the algorithm, so it was designed to play a game, and the algorithm recognized that it learns better, based on repeated patterns, and really just over time learning better and better as it has more and more experience. And so instead of focusing on the end goal, which is to win the game, it actually created more, it opted out to actually creating more havoc and more destruction, because then it could learn more and get stronger and better, right? But that defeats the end purpose. So they had to, so it was destructional, right? So they had to actually stop and build in a human design, an input of a human designer that can kind of nudge it to the right direction. I know we'll start with you, Jay, first, since you're the expert on safeguards. Your take.
Okay, so that's a short question.
So an example on kind of a doomsday example, on when you design an algorithm that is so strong, but then it actually creates more damage.
Yeah.
And
So one thing we do have to worry about is feedback loops. We take in the best signals that we can. We build models. They start blocking stuff, and then if we don't design it carefully, the next iteration will see, oh, all this stuff was blocked. I'm going to block all the stuff that was like it. So if you were wrong, that can quickly snowball and block everything. Or conversely, it can learn, oh, all this stuff was good, I'm going to let it all through, and then suddenly you're, flooded with spam. So there's a lot of care is taken to avoid these types of feedback loops, and to put in kind of corrections that if we see sort of user reports or other external data that we're getting things wrong, to automatically correct back towards the center, and improve the experience. And it's also about trading off. I'm sure this is in any machine learning situation, it's trading off false positives and false negatives. Right? What is the cost of getting it wrong, sort of one way or the other? Especially what we're doing is classification. And is this spam? Is this allowed or not? Maybe a little more subtle when you're saying, is this the right translation of a document?
Yeah, what is I'm curious about Intel? Intel has some innovation in this space. From your experience, from eBay.
What I was going to say is, I think people talk about doomsday as being something in the future, right? I think we have a lot of problems right now. Like, if you look at data that is very biased, right? There's a lot of systems that we build, and they have inherent biases that can create a lot of problems. I mean, if you remember, or they don't have the self-correction mechanisms, right? Like, if you remember the TIE, I think it was the conversational agent that Microsoft built a while back, it became like Nazi, like 15 hours or something, right? And it was like saying outrageous things and emulating the teenagers, really, right? Or if you
Irrational behavior.
which actually was part of what he was meant to do, right? But I think one of the things is really understanding how the technology works, understanding that data can be biased, that people are going to try to misuse it, and really when you release technology, be watchful of that. Right? Really watch the reaction, really watch how it's working, and control for it. I think that's very important.
don't have necessarily an exact example from Intel, but I do agree that we have a lot of problems now, and I don't think that the doomsday that Elon Musk worries so much about is close. We do not have the AI that's that intelligent yet. It's not even really on the horizon as far as I can see, but what is on the horizon, what is here, is that humans train with biased data, because the data is given by humans, and it represents, the AI represents what is in the data. It's not ever gone much beyond it, really, and I would be more worried about giving it adequate bias-corrected data, so that if you do recommendation, recommend that it adequately represents the membership base. It's really much more pressing problem, I think, than the doomsday scenario, or to quote a gentleman who gave a talk at LinkedIn recently, who was in the camp who does not believe in the doomsday of AI, who said, we will worry when the self-driving cars, you tell them to go to work and the self-driving car takes you to the beach, then we will worry. But it's not yet close, I think.
Well, it's kind of tragically, a self-driving car did kill someone.
That is tragic.
Very recently.
But it didn't take me.
Yeah, but in general, I also am not so worried about Elon Musk's doomsday scenario. All we have to do is blot out the sun, and unless the machines can find a new form, there are two examples I can think of where models can go off the rails if you let them. One is, again, feed ranking, where the training data for feed ranking comes from posts that you've seen, and either you clicked on them, or you didn't click on them, you shared them, or you didn't share on them, you comment on them, or you don't. And the problem here is that the data you see is very biased. It's biased by the existing ranker. So you will see maybe your top 10 stories. And yeah, you can correct for the bias in terms of the position among the top few dozen stories, sort of well, through various means. But when you get down to like the 500th story in your ranked list, which you'll never see, how do you know that you would love that story? That's really hard to say. I mean, if you ask people who work on feed, they'll probably tell you, well, I mean, the heuristics threw this away because it's just so unlikely that they would have enjoyed the story that we feel safe. And for stories in the 100 to 200 range, you can try some random explore exploit just to verify. But in general, I don't think there's a good solution here. Another more subtle problem we have with Smartiflies is that we're showing, someone sends you a message, we suggest 3 things to say in response. The problem now is that we're really driving you towards those 3 options. It's a lot easier to click on one of them than to actually type in what you would have really wanted to say. And as a result, we're kind of narrowing down the vocabulary that people use in messaging, which is a real worry. And it's not like we can disable smart replies for a certain subset of users and say, oh, too bad, it's your job is to write as data. So we really have to think hard about how we can avoid going too far down this road and degrading user experience and perhaps the English language.
Great, so I think we're close to the end, so just to sum it up, so just take a moment, 1 minute each, to testify the aspirational part of the topic comes in. What are you most aspire for in AI? What are you most excited about? Yeah,
in the near term, I think that new infrastructure technologies are making machine learning models easier and easier to train. They're lowering the expertise bar you need to train the models, and they're also resulting in higher quality models. Similarly, a growth in maybe not the speed of individual machines, but the number of machines or the number of transistors in a graphics card, for example, the number of GPUs on a graphics card, and the perfection of graphics cards for machine learning tasks means that you can train more and more models in a given amount of time. So you can now afford to have someone who they work on a product, but they're not machine learning experts, go and just say, yeah, go train me a pretty good model. And you can then explore a wide space of models, have it automatically pick the best one, and off you go. This doesn't really help you in terms of the cutting edge, like self-driving cars, but for the myriad of little applications that startups are working on, the smaller products and features that you see at large companies, this could be really helpful, both in driving down the cost of AI and just generally making it more accessible. And then in the longer term, I think that things like self-driving cars are transformational technologies. They're really going to change the way and location that people live in, which may have dire effects for property values.
Yeah, we're going to have side parking spaces.
So the question is, what is most inspirational.
What do you aspire for in AI, and what are you most excited about?
So I aspire to have the kind of machine learning models that both represent humans and serve humans the best of all cultures and languages, because I'm an international engineering team member and I really believe in this mission. It's really important, and to move it as far away from being from carrying the unintended bias of being built by mostly English speakers, to make it accessible to the world. And I believe that that goal is definitely within reach, because we have critical mass in other places other than just English-speaking countries. And yes, I also believe that new technologies, even though sometimes they don't perfectly work right away, are the way of the future, and we must not be afraid of them, we must embrace them. And through trial, we will get to the better place.
For me, I think the first thing that comes to mind that I think is going to be a big change is scale. I think AI is getting to the level of HPC, high performance computing, where all of a sudden you can solve problems with like massive amounts of data. We're not talking about a language model. We're talking about, for instance, a hurricane that is coming up, and you can actually now predict its path with very high precision, and you can say, those 2 streets, you evacuate everybody, right? Now, you can do that today, but it takes a month, right? So by then, the hurricane is gone. And you want to do that real time. And we're getting to the point where we can actually have the performance power computationally and the software to do that, right? They're using a massive amount of compute and the technologies that they have for AI today. I think beyond that, there are 2 other things that I believe are going to be very transformational for AI. One is transparency. Today, like we talked about diagnostics, for instance, right? But the reality is we don't understand how those diagnostics are done. So a doctor runs the diagnosis in the computer, he gets the results, oh, this patient's going to die in 3 weeks. But he doesn't know why the computer decided that. So how do you give that notice to a patient, right? The patient's going to ask, why is that? How do you know that? And you're going to say, the computer told me so, right? So I think building methods for transparency into AI is going to be very transformational as well.
I guess in terms of AI in general, I'm excited about things like self-driving cars, because then my kids won't have to learn how to drive. In terms of my field in particular, I think AI will allow us to adapt much quicker as things change. It takes taking much of the effort out of what we're doing now to figure out what's going wrong. Unfortunately, I want to paint a darker picture, because the adversaries also have AI, and you can so it's going to be this. It's always going to be this adversarial game. And our hope is that we just increase the cost enough so that it becomes not worth it for them to try to take advantage of people on the internet who are always there using systems more and more, and always getting more and more connected.
The good guys with a more advanced chips.
There are more than that. But yes, we have more data, more powerful data, and the hope that we can use the techniques to harvest it more intelligently and stay ahead of the attackers.
So the things I'm most excited about the next generation of AI, I would two ways, like technically, AI has been very powerful on like perceptual problems such as like image recognition, speech recognition, but for the like cognitive problems such as like language understanding, this kind of thing, which I think require more comprehensive intelligence. So now the current artificial intelligence is, I think, it's not comprehensive enough. But I think more and more people are now focusing on to work on this cognitive problems, which require more advanced intelligence. And I expect this problem will be like there will be at least big milestones in next few years on this type of problems. That's one thing on the technique. That's like what I think. The other thing I'm really excited about is healthcare. So I think Luis also gave example like now like in using like you can take a picture of your MRI or CT and this kind of things, right? So the precision of AI model can it can be better than average expertise, and maybe like I think the expertise or like really top level of doctor is really like the resource is really limited. So like the wide application of AI can really help at least like pre-select or like do a first selection of people, so then it can save a lot of resource and also like make people accessible to those like very experts, to people who really have this problem. Because I know a lot of people may like, I'm not sure what's the number, like hospitals, we can use AI to pre-select them and then let the real expert doctors working on people who really need help. So that's two aspects I'm really excited about.
My inspiration for AI is empathy design, so I'm more focused on that. So with a huge shift in computing, with voice activated products, it's going to have to be computers and applied machine learning models are going to have to be much more harmonious with human behaviorism and adding the concrete culture factors in it. So thank you so much for this time.
Good to see you too. So, I'm just going to say a quick little thing and then turn it over to you guys. We actually